All right, so tonight we've got conditionals, errors, and debugging. Those are chapters 5 and 6 in your book. And we're also going to talk about pair programming and give you guys a demo. In fact, a couple of your TAs have volunteered to give you a demo, which is super cool. So we'll do that before we get you guys going on your studio. So yes, there you have it. And don't forget, tonight's studio is actually chapter 4 since we decided to switch them around. And we will come back after that. We might come back a little later than 8 o'clock. I'll let you know depending on what time we get you guys off to studio, what time that's going to be. But we will come back for review of that studio afterward, and any questions you guys have. Okay, again, assignment deadlines. We moved the deadline for part 2. So part 1 is due this Thursday. If you haven't turned it in already, do that as soon as you've got it done so your TAs can grade it. They will thank you for not waiting until the last minute. But part 2 is now due on Thursday, the 6th, to give you a little bit more time because you need to know loops to do that part, and we aren't actually teaching that until Monday. So we're moving that back. And then the entire thing, again, the enrollment deadline is the 10th. There are a couple of other announcements that I did not put on the slide. I think that Clark actually posted them in the announcements channel. One is that there's the TA office hours document is out. He linked it in the announcements channel, but there's probably still going to be some people adding information to it. So it'll be a little bit of work in progress, but you'll at least be able to see some of the TAs that have office hours posted there for now. And then you can just check back again later. And then there's also going to be the document that you guys are going to use to sign up for that accountability thing we talked about last time. That's going to be coming out soon, and Clark will be posting that.
Just dropped it also in announcements.
Perfect.
Please do that also by 9/29 so we can pay you out.
There you go. Okay. All right. So without further ado, unless Clark, you've got anything else?
No, nothing for me.
Okay, well then let's get right into lecture and talk about Booleans and conditionals and all kinds of fun stuff. This is where it gets good, guys, because you can actually really start to tell the computer what to do. Okay, conditionals is using logic to control outcomes. We're going to talk about the Boolean data type. I'm going to go over data type conversion. There was a little bit about this with strings and numbers in chapter 4. And I didn't talk about it last week because I kind of wanted to talk about them all at once, along with Booleans. So we'll do that tonight. Talk about how to evaluate Boolean expressions, talk about the difference between loose equality and strict equality, the logical operators and, or, and not. And then we'll look at how to form up a conditional statement, if and else statements, and then how to handle more complex logic with nested conditionals. Okay, so the Boolean data type. Essentially, the question is it true or is it false? Unlike numbers and strings, the Boolean data type only has 2 specific values. It's either true or false. It must be lowercase, and you do not use quotes, otherwise it's just a string. And it should have a name that indicates that it's a Boolean. This is another thing, I talked about good naming of your variables, right? So you would use the keyword let, and then you can give it a name. In this case, is learning is a good indicator that it's a Boolean because it's basically asking a question, right? Are you learning? And if the question is true, it's true. And if it's false, it's false. And then the value that you assign to it is either true or false. Okay, and here's some examples. You can do like type of to see how these work out, right? And if you do type of true, you get Boolean. If you do type of false, you get Boolean. And you'll notice that the IDE here, and this is from Replit, actually gives it a special color, right? It's kind of that light blue, and that tells you that it's recognizing that it is a proper value. On the other hand, when you get to type of true in quotes, that identifies it as a string. And if you try to do capitals, like type of false with a capital, it's undefined because it says, you know what, that's not any kind of like valid data type at all. It's not a string, it's not a number, it's not a Boolean. So it just says it's undefined. So just make sure it's just lowercase true or false, just like that. Okay, so converting to a string, you are going to use the function string. This is the data conversion that I said was part of last week's chapter. But basically, you can kind of convert a number or a Boolean to a string, and it's going to take exactly what's there. And then just basically, it's as if you put it in quotes. And that's all it does. It just converts it as is. So for example, if you turn the number 6 into a string, you get, the string 6. So you guys, I actually want to make this kind of interactive, and I jumped the gun. You guys tell me what would happen to 438.2 if we try to convert that into a string?
It would just be 438.2, but in quotes.
Yeah, absolutely. That's right. The decimal goes right along with it. Okay, and then same thing with this, right? That's the same principle. Okay, what about if we take the Boolean value true and feed that in?
It
true.
would also be in true in quotes.
Right, it's just the string true then, exactly. Okay, and then if you convert to a number, you're going to use this function number, and just, that basically you're going to learn more about functions later, but all you need to do right now is know that you can just take this and use it, right? Strings must be composed of digits and no more than 1 decimal point, or else it won't be able to convert it. So if you had something that's other than that, it's basically going to evaluate to NaN, which stands for not a number. And that's a special value of the number type. Believe it or not, that is actually a number. It's just an invalid number. Okay, so converting the string 27, how would that work out?
Be 27 without the
27.
quotations.
Oh, I forgot it. I forgot a point. Okay, sorry about that, guys. I got ahead of myself. But yes, it would be 27, and I'll bring that up. Let me talk about this. The Boolean value true actually becomes 1, and the Boolean value false becomes 0. It's that, binary 0 or 1 thing, right? So that's going to be helpful in a second. Okay. So yes, you get 27. What about, dang it. All right, I'm going to get my clicking under control, guys, I promise. But yes, the string hello would evaluate to not a number because it is clearly not a number. What about false?
0.
0, that's right. And what about the expression 3 times 2 as a string?
Would that evaluate to 6, or would it stay as 3 times 2?
That is the question, isn't it?
Not a number.
In this case, actually, it's going to be undefined because it doesn't even know what to do with it, essentially. So yeah, sometimes you're going to run into that where it's actually going to say, wow, I don't even know what that is, because it's trying to convert it, but then it doesn't know how. So yeah, surprise, surprise. Okay. So now we talk about Boolean, and this was in your chapter 5. And essentially, this is not quite the same thing as saying I'm converting something to something. I mean, you can talk about it that way, but I would rather you think about it as evaluating a non-Boolean value as a Boolean. So you use the function Boolean with capital B, and the number 0 and not a number are going to evaluate to false, but any other real number is going to evaluate to true. So what this really is about is whether it's something that actually has any substance to it or not. So where numbers are concerned, 0 and not a number are considered false, and everything else is true. If you're talking about strings, an empty string is considered false, but a string that has a length greater than 0 is going to evaluate to true. So that's really all there is to it. It's just, does it have substance to it or does it not? And you're going to learn about this later. This is chapters 8 and 12, but just so we kind of talk about it in this context, empty data structures like an empty object or an empty array, those also evaluate to false because it's the same concept. So you're going to hear these terms truthy and falsy sometimes used to describe this, where something, you might say, well, we'll do these examples and you might say some of these, like, how would you convert that to true or false? But yeah, let's do it. Okay, so Boolean of the number 4, what's that going to be?
True.
It'll be true. That's
True.
right. And Boolean of 0,
False.
right. The string hello
True.
and an empty string,
False.
false. Okay, so you feel like you got a handle on that?
Yeah.
Yeah, that's pretty much the deal. Okay. All right, so Boolean expressions. This is where you start getting into these operators, right? These equality operators. So let's just run through those. You've got is equal, is not equal. And you use that bang with a combined with an equal sign. Greater than, less than, and some of you are totally going back to like elementary school now, right? And then greater than or equal, and less than or equal. So these are the, somewhat familiar. You've used them before, used them in, pre-algebra and all kinds of things. But these are what are valid syntax for JavaScript. Okay. So let's look at these examples. 4 equals 4. How would that evaluate?
True.
True. And 8 is less than or equal to 8.
True.
True.
Right. 2 is not equal to 7.
True.
True.
Also true. 11 is less than 4.
False.
False.
Right. Okay. The string hello with a capital H is not equal to hello with a lowercase.
True.
True.
That's true. And I think a good distinction to make here is that when JavaScript is evaluating this, it's actually comparing the real characters. And so it is case sensitive, even in a string like this, because capital H and lowercase h are not the same character. Essentially what happens, well, I'm gonna talk about that in just a second when we get to the loose equality, but yes, it's true. Okay, but see, capital G goodbye equals lowercase goodbye would then be
False.
got it. Okay. All right, somebody's got a lot of background noise, so if you don't mind muting yourself when you're in between speaking, that'd be awesome. Thank you. Okay, loose equality versus strict equality. So the double equals and triple equals thing, right? You can read about this in the chapter. They go into quite a lot of explanation about it. I'm going to try to keep this simple, but you can definitely read more about it if you understand it in greater detail. You have 2 operators, right? Loosely equal and not loosely equal. And then you also have strict equality. I can't remember in which, oh yeah. So what's happening here is it converts the data types before it compares them. That's loose equality. So let's look at these examples. 4 is equal to, the number 4 is equal to the string 4. Is that going to be true or false?
True.
True.
It's true. Yeah, because if it sees a number and a string, it's going to say, okay, there's a number here. So I'm going to try to convert the string to a number and then compare them. So same thing with the next one. We've got the string 8.0 is not equal to 8. What's that going to be?
True.
False.
False.
Mixed answers. I love it. Yes, it's false because it can actually take that string and evaluate it and say, oh, that's just 8. 8.0 and 8 are the same thing, right? And so then it compares 8 against 8 and it ends up being false. Okay, an empty string is equal to false.
True.
True.
That is true because of that, falsy thing we talked about, right? And true is not equal to 0.
True.
True.
Correct. Okay, because we know that if you have to evaluate 0 to a Boolean, then it's going to be false. And so that's essentially it. It's always going to default to trying to compare numbers if there's a number present, but it'll default to comparing Booleans if there's a Boolean present. Okay, so strict equality. Strictly equal is represented by 3 equal signs, and not equal is one bang, two equal signs. This is what you will use most of the time, because in order to do a good job of coding and make sure that your values are exactly what you think they are, you typically want to try to evaluate them on a strict basis. But let's see what this looks like. So 2 is strictly equal to the string true.
False.
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 I skipped a bullet point. It is false. That last bullet point, the data type has to already be the same. That's really what it boils down to. Okay, so then empty string is equal to false, strictly. No, that was supposed to be strictly.
If it's strictly, it's false.
Strictly, it'd be false, yeah.
False.
Yeah, strictly be false, and I screwed up, and I can't fix it right now. So yes, I will fix that before I post the slides for you guys. Sorry about that. That's what I get for copying and pasting. Okay, so yeah, what you see is true. If it was strictly equal, it would be false. Okay, 8 is not equal to the converting the string 8 to a number.
Is this false? I think this is false.
False.
I think this is false.
It is false, absolutely, because somebody tell me why.
Is converting the string with 8 in it to a number so they're the same value?
Exactly, because you have explicitly converted it first. So this is a handy thing to remember. You want, like I said, you want to use strict equality wherever possible, so you control the values by explicitly converting them in order to be able to compare them when the circumstance calls for it. And you will have things coming up in your assignments, if you haven't seen them already, where you'll need to do this. So just keep that in mind. Okay. Now we'll talk about these logical operators. There's and, or, and not. And is pretty straightforward. You use this double ampersand to evaluate more than one Boolean expression. And all of them must evaluate to true individually for the entire thing to be true. So it's both and. So let's look at these examples. 8 is less than 9, and 5 is loosely equal to the string 5.
True.
That's true because they're both true. Okay, 2 times 2 is less than or equal to 4, and the strings A, B, and C are strictly equal to the string ABC.
True.
True.
That's true. That's correct. Okay, high equals high, strictly equal, and 7 is less than or equal to 11, and 3 is strictly equal to the string 3.
False.
Right, why?
Because of the string, not a
Because
number.
of the string.
Yeah, that's right. That very last one is actually false because it's strictly equal. So because it's false, the entire thing has to be false because these are ands. Okay, good. Now let's talk about or. Use the symbol double pipe is what that is. If you haven't found it on your keyboard yet, it's up in the top right as part of the, it's basically like, shift slash backslash. So this will let you evaluate more than one, but have the idea of it being one or the other. So only one of them has to evaluate to true for the entire thing to be true. They don't both have to be true. So 8 is greater than 9, or 5 is strictly equal to the string 5.
False.
False.
True.
False.
True.
False.
True.
False.
False.
Okay,
False.
we have some disagreement, but
False.
it sounds like the more you guys think
Oh.
about this, you're coming around to it. So yes,
False.
it's false because neither of these are true. If this was a loose equality on the 5s there, then it would be true, but it's not. Okay, so the second one is 2 times 2 is less than 4, or A plus B plus C equals ABC.
True.
True. True.
Yeah, that's true.
True.
Because
True.
even though the first one is false, the second one is true. Also, may notice something before I move on here, that I have parentheses around these expressions on the first one. And on the second one, they kind of look a little bit lighter. And then on the third one, I don't have parentheses at all. So one of the things that your book talks about is this idea of the order of precedence, right, of operations. And these logical operators will always, they're very low priority. So basically it means they're going to evaluate those last. So you don't have to put things in parentheses, and you can see I've done this on the third one, and it knows to basically take anything that's to the left of that and compare it to all the things that are, you know, to the right of it. So it's very easy. The only thing is I've made these a little darker, so it's easier for you to kind of pick it out visually, but on your code, it may not look that way. So sometimes it's easier to use the parentheses just to make it easier to read, but it's kind of up to you. But yeah, so let's look at the third example. Lowercase high is equal to uppercase high. 7 plus 3 is 11, and 3 equals the string 3.
True.
True.
Yeah, it's true, because that third one is actually a loose equal, right? So it's going to evaluate that string to a number, and then they're equal. But the other two are false. Yeah. Okay. Good. Now let's talk about not. Not uses this bang symbol. It's an exclamation point, but we call it a bang to get the opposite value. And bang goes directly in front of the expression of the variable name that you're using. But you must use parentheses if you want the opposite of an entire expression. So generally speaking, the bang is going to be evaluated first. So in this first example, where we've got is even equals false, and then we're checking the value of not is even, it's just going to evaluate it immediately, right? So what would that be? What's not is even?
True.
True, because it's just the opposite of false. That was a pretty easy one. Okay. But let's look at these expressions, right? So we have not, and then we want to evaluate the entire expression inside the parentheses before getting the opposite value. So the expression inside is 6 times 4 equals 24. So what's the value of that?
False.
False.
Well, technically the parentheses is true, but because it's not true, it's false.
That's exactly right. And I have my transitions out of order. So let's do the next one, and then I'll put them both up there. Okay, so the string A plus B is equal to the string A space B, and that entire thing we want to use to find out the opposite.
True.
True.
Yeah, it's going to be true because we don't actually have a space concatenated in there, right? So those are not equal, but the opposite of that is true. Exactly. Okay, and then like we said, this one's false. Okay. So these are going to be handy because they're going to be times when you want to do things one way and times when you want to do them the other way. So let's talk about these conditional statements. Okay, this is we're starting to get into some more complex syntax. But this is good. These are building blocks for you guys to be able to write more complex code. Reminder on the mute button again. Okay. The if statement, let's talk about this a little bit. Hang on just a second.
I have a question about 2 slides ago when you get a chance.
Yeah, we can go back. Thank you. The whole thing. Okay, this one?
Yeah, the middle, and I don't even know if this would make a difference in this scenario or if ever, but in the middle of the 3 equations, I read it without the parentheses. I would have read it the way that you did it, but generally, I mean, I know you go from left to right, kind of generally, but I thought the equals, what's equals is the equivalency, or in order of operations. I thought the equality symbol,
yeah, okay,
precedence over the logical,
it does,
types.
Right? So it basically means that yeah, and so okay, so let's talk about what you said about the left to right thing, though, because that's a good point. What JavaScript is going to do here is it's going to go to the first one, and it's going to say, is that true or false? And then if we were on the previous slide and we were doing and it found out that this was false, it would just stop. It wouldn't even look at the second one because it knows that they all have to be true once it gets to the and operator. But in this case, it's false, but it's going to move on. So then it goes and looks at the next expression, and it evaluates that entire thing before finally deciding what really has to be done here. So yeah, that double equals is definitely going to be evaluated before it then says, okay, so let's just double check here. We have true or false, or in this case, false or true, right? And one of those is true, so we're good. Does that make sense?
I think so. Yeah. So you could remove all the parentheses and you'd still would focus on the or.
The or would be the last thing. Yeah. The last thing. It's going to evaluate, because it's an or, it's going to evaluate each of the expressions and then it's going to say, you know, is one of them true?
Okay. All right. Yeah, that makes sense. Thank you.
Yeah. And that's kind of why I want to talk about the parentheses thing, because having them makes it clearer that you've got a whole expression there that's being evaluated against another one, but you don't have to have them. Okay, let me skip forward to here. Okay, if statement. All right, use the keyword if, and you follow with a condition in parentheses. This is the way the syntax works. There are some languages where you don't have to do this, but JavaScript is not one of them. So you put this condition in the parentheses and it knows to evaluate what's in there. And that's the basis on which it will either execute or not execute the block of code, whether that's true or false. So you're going to use these curly braces, and people call these a lot of different things. I like to stick with curly braces just because when you talk about arrays, you're talking about brackets. And then you can say brackets and no one gets confused, whether you're talking about braces or brackets. But you might also hear these called curly brackets or other things. So as long as you're just clear, but I'll refer to them as curly braces or even just braces. That is going to enclose this code block that only gets executed if that expression, that condition evaluates to true. That's in the parentheses there. So if the condition's false, it's just going to skip that code altogether. It just moves on. And then you want to make sure that you indent whatever the code block is that's inside the braces. That's the clean code way to do it. Makes it easy to read and follow the logic, which is important not just for you finding your own mistakes as you're trying to figure things out and to read it properly, but important for other people coming along to be able to read your code. You do not want to use a semicolon at the very end. That's actually, that would cause an error. So you do continue to use semicolons with all of the lines of codes you have in the code block inside the braces. You just don't put a semicolon after it. So this entire thing is an if statement. If is the keyword, X is strictly equal to 3 is the condition. And the code block inside, in this case, it's just a single line, console.log, X equals 3. All right. Meanwhile, you have the else statement. What happens if you have something else you want to do once you figure out that something isn't true? What happens if that original condition is false? So you use the keyword else. You use another set of curly braces to enclose whatever code should be executed if the previous one evaluates to false, and then you, again, don't use a semicolon after the closing braces. So you've got an if block, and then you've got an else block. And you'll notice that these kind of overlap, right? That's because these are strung together in a way that makes it very clear that it's a mutually exclusive thing going on here, right? You're either going to have greeting equal welcome or you're going to have greeting equal welcome back, but it can't be both. And this is the way that it makes it the easiest to read and push them together, is to have that else be connecting those brackets at the end of the if block and at the beginning of the else block. So that is good form. You always want to do it that way. So let's look at what happens when you have more than two sets of conditions, that you might have, something that's not just a binary decision. If you can use else if to connect another block in the middle between if and else. So more curly braces, another code block inside, and it only gets executed if the previous condition was false. And again, don't use a semicolon. Okay, I think I have made that point. So you've got the original if block, then you have an else if block, and then you have an else block. So in this example, we declare the value, the variable description, but we don't give it a value just yet because the value is going to be different depending on these conditions. So if degrees is greater than 85, then we're going to say it's warm. The description is warm. Otherwise, so if that evaluates to false, because let's say it's 70 degrees, it's going to say nope, that's not true. So it moves on, and if degrees is greater than 65, which 70 is, then it'll set description equal to pleasant. But let's say it was 50 degrees outside, then it's going to skip both of these because neither of these are true. And it'll just use this kind of, final block else. And I missed a bracket in there. Did you guys catch that? There should be a opening brace right after else. I will fix that on the slides later. Okay, but that's it. It's just, in cases like this, it's real straightforward. You have three different possibilities, and they all depend on different conditions. So you just use this logic to tell the computer what to do. This is how computers think, and this is how you control the outcome. So maybe you've got some more complex logic, and you might need to nest your conditionals. So this is what nesting looks like. You indent the nested code just like you would if it was just a regular code block, because it's just more code, right? So, and you can do it this a lot of different ways. So you typically just pick one and kind of go with it. In this case, I have chosen to nest an entire if else inside the first if, because I decided to have my logic flow this way. So breakfast is pancakes with a space, because I plan on adding on to this text, right? I want to make this string longer. But what I add to it depends on what ingredients I have, because I've got people coming over, but I don't know how many eggs I've got, and I don't know if I have cheese. So, if I have eggs and I have at least 4 eggs, then we can have some eggs with our pancakes, but I might also have cheese. If I have cheese, then I'm going to say that we're going to have pancakes with eggs and cheese, but otherwise it's just going to be eggs. But let's say I don't have 4 more eggs. Let's say I only have 3 or 2. Well, we're just going to have roasted potatoes with our pancakes, right? So the logic follows sequentially. And so it'll start with this very first block here. I'm going to move my mouse up here so you guys can see it. If total eggs is greater than or equal to 4. If this is false, it skips this entire thing and just goes straight to the else. And once again, I'm missing an opening bracket right here. Sorry about that. If this is true, then this will never be true. But it's going to use this logic to go a step further and make another choice of exactly how it needs to be divided up. In your textbook, there's a diagram where they kind of show it more like branching from a tree, right? And it's kind of like a flow chart, right? You got to is this true? Yes, no. And if this is true, yes, no. It's the same idea. It's just this is the way you do it with code. So this nested if else is helpful because there's just one more decision that has to be made if we have eggs, and that's whether or not there's going to be cheese with it. Does anybody have any questions about this? Nope.
This one requires time to synthesize.
I'm sorry,
And more. This one requires time to synthesize and even more examples to help understand further, because it's quite complex, a little bit complex.
Yeah, we're going to have a demo tonight that's going to give you more examples of how to write this logic. And there's also going to be your studio is not about conditionals, but I can cover it again if you guys still want more information when we do the studio review at the end of class. Yes, I have another question.
I got a question. I know you haven't gotten to it yet, but there was a question on the exercise that I kind of got stuck on. It was about sequencing conditionals. If you could just get to that too, because I kind of got confused on that part. I didn't really know how to sequence.
Okay.
Yeah.
I'm sorry, I have not been keeping an eye on the questions channel while I've been talking. Okay, so on the exercises, I don't think I have those up right now, sorry. But I could get them. Hold, please.
That's just if you get to it today. That was my only question.
Then I will, since both of you have asked about this is what I will promise you. When you're going to do your studio tonight, and that will help you work through some of this, and your TA can help you, but I will plan to do something after studio to explain it a little bit more. And I'm also, something that I don't have time for to get through everything is to give you all these extra examples right in the middle while I'm talking. But if you go back and you look at these slides, the PDFs that I put in that folder that's linked in the general channel in Slack, after class, once I get it in there, you're going to have way more examples. That'll be in there tomorrow, because I add those slides in even though you don't see them during lecture.
Okay.
Yeah. Okay. One more question.
So my question is that the reason JavaScript ignores the nested conditional is because of the brackets. It's not because of the tab. The tab is just for clean coding, correct?
Correct. Yep.
Okay.
Yeah, it's just basically evaluating that condition. Total eggs is greater than or equal to 4. And anything inside those brackets is the code that may or may not run, depending on whether that's true or false.
Okay, thank you.
Yep. Okay, yes, so we will definitely talk more about this later. Okay. Let's talk about errors and debugging, and I can't even see my clock because of the Zoom thing. There it is. Okay, just trying to keep an eye on the time. All right, errors and debugging. Finding the source of an error, because you will make them many times, always. So we'll talk about compiling and execution, talk about the anatomy of an error message so you kind of know what to look for when you get all that red text on your screen in the console. Some debugging strategies, and embracing errors and also preventing errors. So compiling and execution, these are the two stages when you have a program that you've written. The first is compiling, which is where your code is parsed and rewritten into an executable file. So this just means that it has its own way of evaluating your code and saying, okay, I know what I need to do to make this where it's ready to run. And so it goes and it does that behind the scenes. And once that's done, it can execute, but it might catch syntax errors for you. And if it does, it'll throw up an error message, and then oh, it couldn't even finish getting the code ready to execute because there's syntax errors. I need to go fix those. The syntax error, which is a specific error type, is very common at this stage. At execution, as long as everything has successfully compiled, the program will run. But you can still have errors after that. You can have runtime errors, also known as exceptions. And a very common one is a reference error, reference error, which is where, maybe you use a variable that you forgot to declare, or you've had, you made a typo and the variable name isn't quite the same, or something like that. There are other errors as well. That's just probably the one you're going to run into the most. However, you can also have your program just not function the way you expected it to, and it's because you have logic errors. There's just something about the way that you've written your code that it's sequencing a little bit different. The logic is going different than you meant for it to, and so you just have to go and investigate that. And later we're going to talk about how you can do that. So let's, now that you kind of understand which errors show up where, at which point in the process, okay, let's look at the anatomy of an error message. So you make an error and you get all this red text in the console. There are actual parts to this. And so the first thing you want to do is look for that file name. And then the second thing is to take note of the line number. And when you have a very small file, which is kind of, you guys are working in relatively small files, less than 100 lines right now, it won't be hard to find what you're looking for. When you're working in a massive code base professionally, this is really important, knowing what file it is and what line it's on. So just so you know, that will always help you find what you're looking for. And then you have the error type. In this case, it's a syntax error. So we go, okay, we've got a bracket missing. We've got, something going on. And the message is invalid or unexpected token, which could mean that there's something there that's not supposed to be there, but it can also mean it's missing something. It just basically, and a lot of times that means, oh, I probably don't have the matching thing. So you know how on those previous slides, I accidentally left those opening brackets off those else blocks? This would be where it would catch that. So in this case, what's the error? Yeah, it's missing the quotes. And you can even tell by looking at the code itself here, if you look back at your code at line 46 there and say, oh, like my IDE is even telling me I've got an error because the string is the only thing that should be orange. And then that parentheses, that closing parentheses should be white, right? Because it should be, the string should have been closed. So yeah, you can immediately see the two left. Okay, so you're going to make these kinds of errors left and right, and not just when you're a student. You will make them 10 years from now because we're human and we don't type things perfectly the first time. But this will help you find things, and so these messages are your friends. So you just have to kind of like investigate it, and take note of all the details of this. And then it usually will help you find what you're looking for. I will say, I'll give you a caveat though, every once in a while, you might have like a missing bracket in one place when you have a bunch of nested things, and it'll catch something on one line, but the problem is on a different line further down. And it's just because those brackets have to match up, or the quotes or whatever it is. So if you can't find an error on the specific line it originally flagged for you, look and see what might be happening further down that's related to that and see if that's where the error is. That's very common. Okay, so debugging strategies. This is where you really want to learn to think like a computer. So follow the sequence of the code, top to bottom, generally speaking, for everything you're doing right now. Examine your conditional logic. Because especially when you have logic errors, you aren't going to get any error messages. The console is not going to give you squat. So you're going to have to kind of go through your logic and say, what did I say that the computer is supposed to do if this or this is, true or not true? And then, maybe there's a logic error there. And you have to be really, really detail oriented. So get in that mindset when you come up against an error, and just be patient and just trace it down, and you will find it. And if you get really, really frustrated because you just don't see it, you can get a second set of eyes from somebody. And you can also walk away and come back a little bit later and just with fresh eyes. And then you'll be like, oh, there it is. Happens all the time. Okay. Making good use of console.log. So you don't have error messages, no problem. You can actually put some console log statements in your code, like especially when you're using conditionals, and you might want to have like one inside the if block and one inside the else block so that you know which code is getting executed. And then you can say, oh, that must be the condition that I messed up because it's the code, that code isn't even executing and I expected it to execute. And you just check the values of the variables, like, what is it saying that this variable actually, represents right now, because maybe it's not what I thought it was supposed to be. And that'll help you figure it out. And you can use things like, put titles, console log some sort of title, use new line characters, that's the \n, or symbols or something to make that really stand out in your console and make it easy to see. Because maybe you are printing a bunch of stuff legitimately in the console, like you will for your studio tonight, as a matter of fact. And you want to temporarily print something that is just helping you debug. And so you might need it to stand out so that you can find it in the middle of everything else. Make sure if it's temporary that you mark it with some sort of comment on it that helps you find it and reminds you to take it out later, or to at least comment it out later. Okay. Embracing errors, preventing errors. Errors help you learn. So having a mindset of not being terribly frustrated when you have errors, it's a good idea to get in the habit of now, because this is part of coding. It just is what it is. You're going to have errors and you're going to say, oh, yeah, I'm going to read the error message, or I'm going to, throw in some console logs and figure out where my logic went wrong, but I'll fix it. And so use all these tools that help you get there, because everybody makes mistakes and you'll do it often. And it's just part of the process. So you learn how to deal. And you actually come to a place where you view error messages as your friend, because they are helpful to you in narrowing down exactly what's going on. And then you can also be encouraged that you will get better at this. And ways that you can do that now are to work on small chunks of code at a time. Like, don't just code and code and code and code on your assignment and try to get the entire thing done and then press run. Okay, code a little bit and press run. Stick a console log in there temporarily to make sure the value is what you think it is before you move on. And by doing that a little bit at a time, it's a lot easier to find your mistakes, because you have a lot less changes that you've just made that you need to look at and say, oh, what did I do since the last time I checked this, right? So definitely be sure to slow yourself down and do things very methodically and in small chunks. And graded assignment 1 is going to give you very good practice for this, because we've already broken it down into 3 parts for you, but they're like kind of the instructions are written in a way that help you kind of really just do one little thing at a time. And if you follow that and you don't just try to kind of dig in there and just do whatever in whatever order and do it all at once, you're probably going to find that it's going to go a little smoother, because you will get one part working, another part working, and then it's just a matter of getting it all working together. Okay, so does anybody have any quick questions about errors and debugging?
I got one.
Mm-hmm.
Earlier, you mentioned that JavaScript most of the time would catch syntax errors. On one of the exercises for chapter 2, it mentioned that there was 2 syntax errors in the problem, and I found one and corrected it, but when I clicked run, it still ran it, and I was spent like 20 minutes trying to find the other one and thought Java might have missed it. So does it miss it sometimes, or does it catch it all the time?
If there's a legitimate syntax error, the code cannot compile. So if it's something that really, really matters, then and there are things like we talked last week about how some IDEs, including Replit, don't care most of the time if you don't use semicolons, even though technically you should. And so could have been something like that. That's possible. Put this question in the lecture, the question channel, and tell me exactly where it was in the book that you saw this, and I will look at it while you guys are in studio and then get back to you.
Cool.
Okay. All right. So we are going to talk about pair programming. I'm going to talk about it for a second, and then we're going to actually do the demo. So let's do that. What, why, and how? What is pair programming? It is a method of collaborating with another person to develop a coding solution. It's exactly what it sounds like. It's very common within teams in the real world. I have done this with peers who are kind of at the same level as I was, and we're just figuring stuff out together as we go. I've also done it with senior, engineers who were teaching me things as I was working with them. And so both of those things are extremely valuable, and you will hope to do a lot of that when you get a job. And so why not start now, right? You will get things done faster. So it does make a difference. Two heads are better than one. You've got two different people, one person who has a slightly different knowledge base, different experience, and might think a little bit differently about things than you do, and vice versa. So you can help each other. And it definitely speeds up your learning. You pick up things as you're going. And it's not even just about like solving the problem. You might pick up something cool, like you didn't know that you could use Command/ to comment a whole block of code out. And oh my gosh, that's cool. Thanks for showing me that, right? You learn good things about becoming a better developer from other people when you work together. And it helps you like level you up overall and make you a better developer. And you will come up with more creative solutions. And the code will be better. It'll be tighter, it'll be cleaner. You might start to write things one way and go, oh, wait, there's a better way to do this. And then you figure it out. And it might not be something that you would have necessarily done if you had just done it on your own. And it prepares you for live coding and interviews, and not to scare you or anything, but technical interviews sometimes include live coding. They give you a problem and you solve it right there in front of the interviewers. And it could be, it sounds very scary, right? And it definitely is the first couple of times. But when you guys get to liftoff, you're going to have to do this. I shouldn't say have to. You get to do this, because one of the beautiful things about liftoff is we work with you, your TA and volunteers come in, and there's like a, no pressure situation for you to practice doing this before you actually go out and do real interviews. So that's awesome. But you can get accustomed to this now. And so this is what's going to be so great about collaborating with other people in studio. One person is the driver. This is the person who types the code and is kind of talking about what they're thinking as they do it. That's an important thing about live coding, is that you are voicing your thought process as you're typing. And the other person is the observer, who's watching, kind of thinking about it, thinking ahead, maybe asking questions, catching mistakes. And maybe they're jump over on Google real quick to look something up while you're still typing something else. This is kind of how this goes. This works really well, and why it goes faster and ends up with a better product. And then to do this effectively, kind of in the traditional sense, you would switch roles every once in a while. Tonight, we're going to switch roles every 3 minutes, because we need to keep it short, but we want to give you an idea of what this looks like. So without further ado, I'm going to do the pair programming demo. So this is going to be taken care of by Zac and Sammie, your wonderful TAs. And I'm going to give them a problem they've never seen before, and they are going to solve it for you. So I'm going to stop.
So nervous. All right, so I'll share my screen. Oh, well.
No, this is great. No pressure, because this is literally how this happens. It unfolds as it unfolds, and you just kind of, you're going to get a sense of what this looks like. Okay, I'm going to post, if I can find the chat, because
we need read line sync for this.
No, you do not.
Okay.
Okay, so let me put this in the, I think I'm going to put this in the lecture questions channel, so it's there for everybody. But here's the instructions, and I will read them. You're going to get some cash for your birthday from certain relatives who always give you cash, but you don't know how much. But you already know how you want to spend it. If you have at least $40, but less than 60, you're going to get a new set of basic earbuds. Nothing fancy, but at least you'll have sound in both ears again. If you have at least $60, but less than $100, you're going to get that new bag you've been needing for your laptop, so you can go off to cool little cafes and work on your graded assignments. If you get $100 or more, you can afford to get both. Fancy. So you're going to write some conditional logic, and that prints a statement, and you can decide what that's going to say. But that just says what you're going to buy, depending on how much cash you have. And then you'll want to test it with different amounts to make sure it works as expected.
Sounds good.
All right.
Okay. Let me reread this because I'm going to drive first. So I'm gonna reread the instructions. If you have at least $40 but less than 60, you're gonna get a new set of basic earbuds. So I guess we can just put these in comments, right?
Way ahead of you. Yeah, 40 to 60 basic earbuds. I hope everyone can see the screen okay.
60 to 100 is gonna be a new bag for a laptop bag.
New laptop bag.
Mm-hmm. And 100 or more, you can get both.
Okay.
All right. And then so we know too that we're gonna need to have a cache value, right? So, and that can't be a constant because that could change, right? And if we're programming, we want to kind of think of that as your wallet amount is going to change, right? So maybe I call it wallet, yeah, wallet amount, you know?
That works.
All right.
Can I interrupt for a second? Can you
Mhm.
do control plus plus and make your, I think that's what it is on Windows, to make your text larger? Yeah, there you go. Okay, that'll help everybody.
Awesome. Thank you.
And I don't know, this will change, right? But we can just set it to something, and we're already gonna kind of know what's gonna happen, but
So we'll just hard code it as 80 for now.
I guess so. We don't know how much it's gonna get though, it says, so maybe this is where I could see using read line sync to put in an amount, but we're just gonna hard code it for now.
Okay. We can always change that later.
Yeah, we can switch that up and refactor after the fact. So basically we want to write some conditional statements, right? So if wallet amount is what, let's see, I guess we'll check the 40 to 60 range. So if it's wallet amount's greater than 40 and wallet amount is less than 60, and what are we supposed to output? Just whatever we want.
Maybe console.log. I'll get basic earbuds.
Oh, look at that. See, we need to do double quotes.
$60 is a lot for just basic earbuds.
Yeah, but you know, the beats and stuff get kind of expensive.
True.
Let's see. Then I guess we could move to the next one, right?
Yeah, so now maybe else if,
and we'll just copy this right here. And we'll say 60 to 100. And I'm introducing a logic bug here on purpose, if anybody can spot it. But so then we're going to do kind of the same thing, right? We're going to output less than, or let's see, does it say 100 or greater? Yeah, 100 or greater. Okay, so 60 to less than 100. Okay, so that works. So then I don't know, we'll say something like, I got a new top bag.
Mhm.
Okay, so let me stop you for a second so you guys can switch.
Okay.
Okay. All right, so now I'm driving. And we've got our if and our else if, so I think we can move on to our else statement, which will catch if these happen to be false. So else, we don't even have to put, anything here because it's going to catch anything else. But we don't want an else, do we? Because we want it to be 100 or more. Because what if it's like less than 40? It could be another logic. It could be another logic error that we add. So I'll leave it at else for now. So else, let's say console.log. I will get both earbuds and a laptop. Yay.
Okay.
All
And
right.
then I guess we could try running this, but we could also talk about any issues that might be in there. So we've already talked about the else statement, right? Because we could have less than 40. And we could have greater than 100.
Yeah. And I mean,
So if we have less than 40, it'll still output, I will get both earbuds and a laptop.
yeah, and let's demonstrate it, right? So let's say wallet amount is $20.
Mhm.
So if we run this program, what do we expect to output here in the console?
Yeah, it's gonna be our else condition.
Ah, so it runs and it says, I will get both earbuds and a laptop, but not really possible with just $20.
Yeah, so maybe we should change that to an else if statement.
Right.
And
Else if.
then we're going to want to check in our else statement at the end whether it's less than, right?
Right. So now we can add the else. And we'll just log. I can't get anything. It's so sad.
So, but I still see another issue with this. So because of how it's checking stuff, we may, let's just kind of think this out, or it might be an issue. Because it's going to check each one in order, correct? It's going to check this first. So if it falls within this range, it'll output this. If it falls within this range, we'll output this. Well, I don't know if we'll have an issue. We'll just test it out. So let's
test it.
Yeah.
So $20. Let's go ahead and have this run. Where's the run button? Why am I missing it? Oh, I can't get anything. Okay.
Okay.
So
let's try with exactly 40.
Let's run it.
Oh, so we do have an issue there.
So what's the issue?
Right. I have to look if you have at least 40. So this should be greater than or equal to.
Right.
If we have 40 or if we have 40 or up, we'll get that. But what about with 60? Let's check that out. That's kind of weird, isn't it?
Oh yeah, that should not be happening.
So what if we test it with 61? So I think this should be equal to, right?
Right. Because we have that and statement, so both of these statements have to be perfect.
Evaluated as true. And then same with this one, right?
Right.
And so let's try with 100.
Very nice.
All right. Great job, guys.
Thank you. That was fun.
Yeah, so we have a number of people in the lecture questions channel in Slack who have been talking about alternate ways to do this logic. And let's see, a couple people mentioned that, couldn't you do this in descending order to where you just check for greater than 100 first, and then that rules out anything. So then you could check for like greater or equal than 60. And then you wouldn't have to have the AND operator because you're ruling out things automatically by going in descending order instead of ascending. And that's a really good point. And, this is the thing about this. There are so many different ways this could have been written, right? You probably each would come up with a slightly different way of doing this, and that's okay. And in the end, it really, most of this is simple enough that it's pretty clean either way. So it's just about personal preference. There are going to be times if you're writing more complex logic when there is definitely one way that is much, much better than another. And you'll discover that as you're kind of playing around with things. But it's great that you guys are thinking about these things. You were catching those errors as they were typing them. And that's the value of pair programming is, you guys were watching and you were catching these things. And if you had been in session with one, and they were making these mistakes on purpose, right? But let's say you're pairing with somebody and they just didn't catch it. You could stop them and say, hey, wait a second, I think we're going to have a problem there, right? And that's what you guys were doing over there in that channel. So this is the value of pair programming. You guys help each other catch this stuff and come up with better code and think about better ways to do it or different ways to do it. So this is perfect. Thank you so much, Zac and Sammie, for being our demonstrators this evening. If you want to give me back the screen, I will take this back and introduce Studio. Just got to get my other screen back. Here we go. Okay, so for tonight's Studio, you're going to be going over to chapter 4, and you're going to, everything we talked about in last week's Studio, declaring and initializing variables, and then you're going to print a report that needs to look exactly like it looks in the instructions. So what this means is your attention to detail is very, very important. So and also you can construct strings however you wish. I know somebody brought this up toward the end of class last week about, when do you use quotes? Can you use backticks and, do string interpolation? All those different things. I'm going to show you different ways to do it when we do the Studio review when we come back. So you guys, just experiment with that as you're working on this together. The instructions are in your book. Just go find the Studio for class 4. And then, the way that Zac and Sammie were doing this was one person started a REPL on Replit and then used a button in the top right. And I don't actually have it in front of me, but that's okay. They used a button in the top right that said invite. And then they generated a link from that and shared it with the other person. And then they were both able to sit there and type, as you saw, in the same REPL and work together that way and switch back and forth on kind of who is typing and all of that. So feel free to, just decide once you guys kind of get split up, you can decide who's going to go and create that and then share it together. Okay, let's see. And the last thing I'm going to say before I kick you guys out, just kidding, is that next week we have strings and arrays are the topics sorry, not next week, on Thursday, because yes, it's Thursday. So before class, do that reading and quiz and exercises on chapters 7 and 8. And then also remember that that's the deadline for your part 1 of graded assignment 1. We'll do lecture, studio, and review on strings and arrays. Class 4 on Monday, the 3rd, is iterating with loops. Talk about for loops and while loops, and same thing, chapter 9. Just do the prep work. We'll do lecture, studio, and review. So that's coming down the pike. So for now, you guys head out to your studio. we're about 10 minutes behind, which means you guys, why don't we come back here at 10 after 8? That sound good? All right, so you guys take a little bit of a break. Your TA will tell you kind of what time you guys are getting back together to kick this off. But y'all have a great time, and I'll see you back here at 8:10.